did this one by hand, but then just want to know how to do it like I
All
do it
right.
through Desmos to save time.
You know what? Does that say 68 million or 88 million?
88 million.
All right,
Yeah.
let me copy that down. So it says in a recent year, companies spent a total of 88.1 billion on newspaper, television, and radio ads. Total amount of spent on television and radio ads is only 3.1 billion more than the amount spent on newspaper ads. All right, so I'm just gonna, as I do this, I'm gonna set up some variables. So give me a few seconds here to get the main stuff copied down. So I'm gonna let X be the newspaper. I'm gonna let Y be television and Z be radio. And the total amount spent on, okay, so we know that right off the bat, the sum of X plus Y plus Z is going to be 81.1 billion. I'm sorry, 88.1, my bad. I'll just rewrite that. Okay, and then the total amount spent on television and radio ads was only 3.1 billion more than the amount spent on newspaper ads. So, so television and radio would be Y and Z, Y plus Z, and that's going to be 3.1 billion more than X. So X plus 3.1 billion. The amount spent on newspaper ads was 5.3 billion more than what was spent on television ads. So newspaper ads is X and the television ads was Y. So X is going to be Y plus 5.3 billion. And then how much was spent on each of advertising? Okay, so um, are those answers correct that you have there?
Yeah, I was just trying to figure out like how to put it into like the matrix form
Oh,
and
okay.
use like the like Desmos calculator for this one. Just to save like time so I don't have to do it by
Yeah.
hand.
All right. Go ahead and unsave or stop sharing, and then um, I'm going to go to my overhead first. Oops, didn't need to do that. Hold on. Let me pin that.
Okay, yeah, th those are the equations that I had set up, but I just didn't know how to put that into like a matrix for
Okay.
calculator type
I'll,
type of
I'll,
thing.
I'll
So
sh-
yeah.
I'll show you that here in a second. I am recording this, so in case anybody's going to watch this later, I just want to go through a little explanation. The sum of the three types of ads is 88.1 billion. We were told that TV and radio, Y plus Z, was 3.1 billion more than X, which was newspaper. And we were told that newspaper was 5.3 billion more than Y, which was TV. All right. So those are the three equations. So the first thing you want to do is rewrite the system so that everything is stacked. Now, right here, what I'm going to do is I'm going to bring the X over. So it's going to be negative X plus Y plus Z. I'm going to leave the 3.1 on the right. And over here, I'm going to bring the Y over. So it's X minus Y. I'll leave some space there at 5.3. So do you see how I've written the system now?
Yeah, yeah, yeah. Okay.
Okay. So what I'm going to do now is I'm going to share, I'm going to go to Desmos and hold on. Yeah, there we are. Okay. So I'm going to share Desmos here. So I'm going to go to Matrix. Now, hopefully you guys have been playing with this. It's pretty fun. You hit new matrix, and I want three rows and four columns. And the three rows are going to be the equations. Well, it's going to be the top equation, which was x plus y plus z is 88.1. So 1, 1, 1, and then 88.1. The middle row was negative x plus y plus z equals 3.1. So it's going to be negative 1, 1, 1, 3.1. The bottom row is x minus y equals 5.3. So 1 minus 1 and then 0 because there's no z in that. And then 5.3. So far, so good.
Yeah, yeah, yeah.
Okay, so then you hit this little button up here on the lower right, and that enters it into the in memory. And then this is really cool. You go to the RREF, that stands for row reduced echelon form. And what that does, and then you just type in A and let it does all the work for you. Isn't that awesome right there?
Yeah, yeah, I've been enjoying that part of the calculator for like the inverse and stuff like that.
Yeah, there's actually a lot of ways you can solve systems using matrices. And this is probably the fastest, especially for problems like this. And so the answer, I'm going to write down the answer. If you look at it the way it's written here, this is your x. You see, I don't know if you can see my cursor. Let me see if I can.
Yeah.
Yeah, there's the x, and that's 42.5. There's the y, that's the 37.2, and there's the z, that's uh, um, the 8.4. My bad. I was writing stuff down as I'm talking.
Of
And
course.
then and then that's it. You just peel off the answers and you are finished. And by all means, don't do this by hand. You'll be here all afternoon. I'm going to stop.
Oh yeah, that's what I've been doing for a lot of the system of equation problems and the practice and everything. And I've just been solving a lot of them by hand, especially when it's like the multivariable ones. I just kind of do that one by hand, and it just
No.
takes me a long time. And then I recently looked at that discussion, and then I was like, oh, I guess we can use the calculator. So I've been trying to play with that for the past couple days, and
Well, on the test, you can
just
use
grind out.
Desmos.
Okay, okay,
So
yeah,
practice these on Desmos.
yeah, that's why I've been trying to like learn how to convert all of the like equations that I've been doing into the matrix form. So that way I
Uh-huh.
can just plug it into Desmos and have like Desmos basically just do the like arithmetic for me. And that way
Yeah.
I don't have to
Well, but your job is to get this right.
yes, yes, of course, yeah.
If you get this
I
right,
had that first equation, that first part that you have, but then I didn't know how to like I didn't know what the next step really was to just convert it into the second form.
okay.
So that way I could put it into the matrix form. But this is a lot clearer now.
Well, if you were to do this by hand, it would probably take you a half hour.
Yes,
If you set
yes.
this up correctly and you set this part up, you do the little translations down here to make it look pretty, then it's really just a matter of typing it in correctly on Desmos.
Of
And
course.
at that point, it'll just spit out the answer for you. I don't
Of course.
care really honestly about doing all the algebra in between. What I care about is that you can understand the problem enough to set up the original um, set of equations right here. And then if you get that right, then assuming you don't make any mistakes in the translation, you should be able to get the right answer from Desmos.
Okay, for sure.
All
For
right.
sure.
Any
Okay.
other questions on this one? Okay.
Questions on this one, but I
Go
do
ahead.
have a question on a similar one.
Yeah.
So I've been using the Desmos one, but I noticed for problems that had X's in them, variables, it was not letting me do it in Desmos. I had to do it by hand. Is there a way to do it in Desmos using when it has variables, or is it not
Well,
possible?
again, can you give me an example? I can bring it up on my lab. Do you have one hand?
Um, it wasn't on the practice exam, but it was on some of the mastery points. And it
Well,
was
I have the mastery points up.
let me find it, but it was the one where you had to use the inverse method. And it was like it had the x's and like 2y. And then you had no, I just had x's. So it's like x to the third, x to the ninth. And then
Oh
you had
yeah.
to do the cross multiply with it.
Um, again, unless you, if I could give you, can you share it on your screen?
I'm looking it up in my notes right now.
Okay, because if you give me a problem number, because I've got my study plan up too, and I can always just bring up a problem that way. And honestly, you don't have to do if it says use Kramer's rule, you don't have to do that. Normally, when I teach this, I usually don't care how students solve it. I just say solve it. To me, it's more important that you set it up and solve it. Okay, so I'm going to share what I've got. You tell me if this is what you were looking at. Is that the one you were looking at?
Yes. Yep.
Evaluate the determinant. Okay, well, that one we're just gonna have to do it the old-fashioned way. I'll show you how to do that. Let me copy it down. So this is 11.6, number 10. It's actually the first practice set under the 11.6 header. And it's a 3 by 3 matrix. It's x, 0, and -2, 4x and x squared, and -2x and 1. So we have a 3 by 3 determinant. And all right, so I'm going to stop the share. Okay, so um, yeah, I guess that Desmos will kind of trip up on this because it needs a number there. Um, so I'll show you how to do it by hand. What you do is you pick a row or column, and I'll just pick the top row. And you just write out the elements, and you give yourself some space. And what you're actually going to do is you're actually going to create what are called cofactors. Now I'm going to write this out first. So what you do is you take the elements in the top row and you write them like this, but notice that I put small brackets next to them. These are going to be the minor matrices. So the minor of x is to basically ignore the row and the column that x is in, and what you get here is the minor. So that's x and x squared and x and 1. The minor for 0 would be ignoring that row and that column. So 4x squared, -2, and 1. And then the minor for the -2 over here, we cancel out this column, and it's going to be 4x and -2 and x. And now the other thing you have to do is put in the signs. And if you do the top row always, it's always going to be plus, minus, plus. These are called cofactors. Okay. All right. Now what you do is you do well, first of all, the 0 is good. The 0 just cancels out this guy entirely because it's just times 0. What you do next is you just do the determinant, the 2 by 2 on each of these little guys. So the determinant here would be x, take away x cubed. Meanwhile, this x is out in front. This guy we don't need to write at all. And then here I'm going to have 4x. Now be careful, it's going to be minus a -2x, so plus 2x. And then all this by times -2. And then I'll just clean it up a little bit. It's distribute, I get x squared, take away x to the 4. And over here, well, this is 6x, so -12x. And you put them all together and you get, well, basically what you see there, -x to the 4th plus x squared, take away 12x. And that's your answer. Okay, that's how you do a 3 by 3 determinant.
Thank you.
I don't think Desmos will do it with variables. Did you try it? What did it say?
Yeah, I tried putting in different variables, all sorts of things, and it wasn't working out. And then I just did it by hand. But I was asking because I was wondering if there's maybe a method I didn't know of how to put variables in there. But
No, well, you can. You're certainly allowed to put letters, so to speak, into a matrix. But unfortunately, it looks like Desmos chokes on it. So as long as if you have just numbers in your matrix, then Desmos will carry the day. But as soon as you have variables, you have to actually work it out the long way. Is there any questions on any of the calculations that I did there?
Not on the calculations, but will something like this actually be on the test? I should be able to
Well,
like actually solve it by hand then, or just rely on Desmos to calculate our matrix stuff.
almost all of the questions that you can do where it's an application question, you should be able to handle using Desmos because you'll be given numbers. As far as will you see this, I can't really say because if you do your practice or your review, that's usually a good indicator of what's going to be on the test. And the tests are slightly randomized. So because they pull from pools of questions. So I don't want to say no and then suddenly you see it. So I always hope for the best, assume the worst.
Of course, of course. Yeah, I was just wondering because I didn't see this type of question on my practice exam and like on either time I took it. And I was just wondering like when I had matrix problems, I had like either like basic ones or just like inverse or determinant ones where you can just like plug it into the Desmos calculator and it just spits it out.
Yeah.
So I was just wondering if like really it's important to actually know how to do it by hand when a lot of stuff that like um if it's just all numbers then you can just plug into Desmos. So I just want
Um,
to know if I have to like
well,
refresh
like
my
I
skill.
said, assume the worst, hope for the best. You know what I'm saying?
Got it, got it.
Um, if you see a question like this one, I would imagine you just see one, and most of the rest of them you can use Desmos to solve. And as I was looking through the questions in your study plan, I got the same study plan as you do. Um, I noticed that they'll say something like use Kramer's rule or use, I don't know, some other method. Honestly, I don't really care what method you use. So if you like the RREF method, that's great. Um, as long as my main concern is that you understand the problem well enough to translate it into something mathematical, and then you do the thinking, and then Desmos just does the calculation, and that's really what I'm going for. So they're not, basically you can use whatever method as long as it's legal, whatever method works for you.
So following up on that, so then would you recommend us going over mastery point problems that, for example, aren't on the practice exam but could appear on the actual one, especially word problems? Because
Uh,
last exam I had three questions that their formulas, like the way they were formulated, they were not on the practice exam, but they were on the mastery points.
well, okay, so the mastery points are like the big list of homework, right? And then it kind of funnels down. So it funnels into what's on the practice test, and then that funnels down into the actual test. Does that make sense? But
Yes.
you shouldn't be seeing anything on the test if you haven't seen it on the practice test. Correct me if I'm wrong, but you shouldn't.
So last test, there were three, because I did the practice test twice,
Okay.
uh, quite thoroughly. And there were three questions that there were two of them were word problems, and those were not on the practice exam, but
But
they
they were
were
on.
on the mastery points.
Well,
Um,
okay. So the mastery points is the biggest set. So you're going to see questions on the mastery that you won't see on the practice. So you should not be it shouldn't skip over. In other words, if it's not on the practice, it's not going to be on the main test. That was the way the course is designed. Now the mastery, I'm sorry, the mastery points is just really meant to give you guys like a lot of exercise. So you're going to see a lot of stuff that may not translate onto the uh, review tests. And then, of course, that should be what you want to study for the main test.
okay, so that's good to know because maybe I don't know. Okay, so that's good to know because last test, th there was like a specific word problem on the exam we took, that the one I took, that wasn't on the practice exam. So, but we should just worry about the practice exam. Maybe that was like
Yeah,
a
I'll take
outlier.
a look at that. That should, um, there's, see, like I said before, your questions are pulled from pools. So everybody's test is just slightly different from everybody else's test. It's the same test, you're getting like the same main set of questions, but you might see a slightly different question than somebody else, and maybe one, I'll have to take a look at that again. But by and large, if you study your review, that should be really what you want to be studying at this point.
Okay, so I'll probably do the review one more time before I take it tonight.
Yeah. Now the test opens tonight, but it's open all the way through tomorrow. So, are there any other questions from the that you want looked at? Any more questions you're wondering how they work? We have a couple new people show up. Hey, you guys want to see a question worked out?
Last time when I Last time when I was taking the test, there was like an annoying bar that said like recording in progress, and it was like blocking half the square root sign on the Desmos. And I was wondering if I click close on that, will I be fine or will it close out the whole program? Because it was like I had to slow
Oh
kind of move my cursor because I was worried about accidentally clicking it.
gosh, I don't know. Did anybody else have that problem? I, you had the same issue as well? All right. So the recording in progress bar is in the way of Desmos. Um, in regards to that, gosh, uh, I, that makes me laugh, frankly. It's like, what else can go wrong? Um, I would be like you. I would be kind of concerned to close it out inadvertently. Did it become like a major issue or was it just annoying?
It was more just annoying and it kind of slowed me down, but it wasn't too
Uh,
bad.
this is one of those things that, you know, where they place these elements can be maybe reconsidered. One of the things that it's always bothered me about, for example, honor lock, is that the button where you do the autofill for the password is usually not very obvious. And we've actually asked them, make it like 4 inches in diameter with yellow and magenta, colors, you know, but they don't listen to us. So you know what? Hopefully it won't be an issue, or if it's there, it's a minor detail. I really don't know what to tell you there. I'm sorry about that. We had a question here. If we do the review question, are they enough for exam two? Yes, they should be. By the time you've gotten to the review set, you have completed, well, you should have completed enough of the masteries to get your mastery points. And that should make you sufficiently skilled to handle the review. And then, of course, you want to do that a couple times for the actual test. Again, I can look at one if you want, if you have one that you're wondering about. Did you have a particular question from the review?
Yes, like a general question about like the test.
Uh,
Since a lot of the stuff that we can do, like with the matrices, are like through the Desmos calculator, do we still need to write it out on like a piece of scratch paper, or if I'm just like looking at the problem and like transferring between the tabs and just like inputting like the the number into the Desmos calculator, do I still need to like put that on my scratch paper, or is that just something that because it's a calculation, I don't really need
it's
to?
up to you. Scratch is just really whatever you need. The scratch paper is there. The option is there if you just need to work something out in your head or something.
Okay.
You and I ask you to turn it in because I will take a look at it sometimes, especially if there's concerns about like how a question was answered.
Okay.
But no, not all questions require that you actually write anything out. Just be careful. If you do it all in your head, make sure your head doesn't drop a negative sign.
Of course. I was just making sure that like if I didn't put like a certain problem down like while solving like a matrice, like I wouldn't get like docked for like cheating or anything like that just because
No,
I didn't like write
no,
that work
that's
out.
that's not. You don't need to be concerned about that.
Okay.
The cheating part comes when you have somebody in the room helping you, or you're looking under your desk every 5 seconds, which we've had people do. You'd be amazed at the stunts that people pull. That's part of the reason I'm so picky about showing your work area.
Yeah, also just general question again, like if I go through the old like honor lock system to set up my environment and everything and it says I'm all okay. Uh but then like I think the last time I had a couple complications with that. Like I just wanna kind of know like
Um,
what would be good because I like had my camera like set up and I'm in like the dorm, so it's not like a great I don't know if there's like really a ideal spot for my
I,
desktop camera and stuff.
I understand that. I understand that laptop and desktop cameras are usually placed in the most awkwardest spots. I don't. It just needs to show your work area and your basically your face. In other
Okay.
words, it doesn't have to be fancy. A lot of people what they did is they just kind of moved the computer to the side, and so it's kind of like a side view. And
Okay.
it's very. It doesn't have to be fancy. It doesn't have to be beautiful. I don't need to see the color of your eyes or anything like that. I just need to see you and your work area. It'd be like if you were in a normal classroom where I'd be walking around. I just want to make sure you don't have anything on your desk or like you have your phone in your lap or something like that.
Of course,
Um,
because I work on like the pull out. I have like a pull out type of thing going on with my desk in my dorm. So like I usually have like a lot of work on that. But then because of that, like I'm a little extended out of the desk. So I just
that's
want to make sure if
fine.
that's gonna be okay.
Right. That's fine. And again, I am pretty strict about this one, but you do, if there's a concern, I will contact you, individually. And
Okay.
I just want people to adhere to the rules because it is important. Um,
Okay.
Look, I've been teaching for 32 years. I've seen it all at this point, and I can usually tell cheating behavior pretty fast. It's like a bad poker player. They just have so many tells. It's almost laughable.
I see. Okay.
And in other words, people who cheat usually give themselves away without realizing it.
Okay.
As long as you are making an honest effort to comply with the rules, that's all I ask. I understand that the desktop cameras or the laptop cameras are not the most conveniently placed things, and people have cramped workspaces, but it's got to be done. So find some way to do it. Some other
Okay.
people have like put it up like the computer, a little like on a stack of books.
Okay. Yeah, I've been able to like I can get my workspace in it, but like sometimes I can only get like half of my face or something, or then like if
That's
not, I get
fine.
my full face, but I can get like my
That's
entire like
fine.
work area.
I just need to see that it's you and your work area.
Okay. Would you rather
I,
see like more of my work area than like anything else or
it doesn't matter. Just as long as I see both.
okay.
And again, I don't watch. What I do is I kind of jump around each video. I take a look at like at the first setup, about halfway through, and then toward the end, and it's like a sampling.
Okay.
And um, as long as I'm satisfied that you're following the rules, that's good enough for me.
Okay. Thank you.
But I solved your problem. I went ahead and extended it a day in Canvas. So it was already extended in my lab. I went ahead and just made the extension in Canvas active too.
Okay. Because I think I was a little bit confused because I thought the due date was tonight from the start. Because on Canvas, when I checked a couple days prior, it said it was 11:59 on the 10th. That's
Hmm.
why so was the original due date last night?
I remember, I don't remember. Yeah, I think it was, but I think that was in my lab. But that being said, I did do a grade dump, but I will be doing another one tonight. So probably a minute. And frankly, since I extended it, I'll probably do another one, I guess, tomorrow night.
Okay. Thank you.
Yeah, I'm sorry for the confusion. Because I usually, honestly, when I'm setting the due dates, I'm usually working within my lab directly. And I've discovered that it sometimes doesn't update in Canvas. So I went ahead and updated it in Canvas. And hopefully that shouldn't be that nutty. Yeah, I'll do another grade dump. Uh, Actually, I'll probably just do it tomorrow night.
Yeah, so I just like
All
couldn't
right,
remember like the graph to use, and I just want to know like why it's C over B. Stuff like
let's
that.
take a look at this one.
Because I got everything else right except for
Yeah,
the graph.
yeah. Actually, the easy answer, the left endpoint is always closed. Um, the way that probability mass functions are set up, you always make the jump. It's always like
Oh, I see it. Okay.
the
Yeah, I
left
was looking
end.
at like the first point here, and then I thought it was just close here. Okay, I see it now. Okay.
Yeah, so the two graphs, B and C, are almost identical,
Yeah, of course. Yeah.
but
Okay.
it's always the left endpoint is active, if you will,
Okay.
because then you get up close to the right endpoint, then you actually just make the jump.
Okay. Of course. Okay. Thank you.
Sure.
Stuff of it. There was a problem. I saw it on the practice exam, and I also remember it from the mastery point a couple weeks back. It was basically the one where you had to state the three rules and figure out if it's a probability mass function.
All right.
And I had this question back then. Basically, I noticed that anytime it violated the first rule, it also violated the second rule. And I was a
Yeah.
little confused about the second rule, the x equals the small x. Like, how does that? I never really understood that.
Okay. Do you have a specific problem or that we
Uh,
can
I'm
look
trying
at?
to I'm trying to find it right now.
Yeah, I'm going through my own. Um, so it's probably 10-1. No, actually not 10-1. It would be probably 10-3, wouldn't it? Identify
On my
probability.
um on my practice exam, it was problem 26.
Do you have
Uh,
it on your computer right now?
I can pull it up because I'm just looking through my notes, but I'll pull it up on the
Okay.
website.
Actually, I can share right now what I have. Um, okay.
So
So,
it was this one, but not this one. I think it was two or three. It was the one where it was not a probability mass function.
okay. Well, let's go through a couple. Um, a PMF, it basically you cannot have any negative Y values. The Y values are your actual probabilities. And the X values, well, it depends on the scenario, but they represent something. So these are just, there's no context here. So I don't know what the 0, 3, 4, and 7 stand for, but they represent something. But the Y values are always probabilities. And so you cannot have negative probabilities. So, okay, we're okay there. Um, I forget what the first, second, and third conditions are, but your the probabilities must add to 1, 0.4, 0.3, 0.1, 0.2, and that works. So this actually is a probability mass function. This one right here. Does everybody see that? So the answer should be D. Let's look at the second one. Ah, this one's can't. That negative is illegal. You see that?
Yeah.
Yeah. Now I don't remember which number that is. Like, if it's the first, second, or third.
I think it's the first one because I was like also struggling with these earlier to like see that like when there is a negative, I think it violates not only like the first condition, but then I think it violates like a second condition as well. But then I
Okay.
wasn't too sure because if you look it up, some people like list the rules differently, like in terms of like what comes first, second, or third. So it's kind of
Yeah.
difficult.
Yeah,
Yeah.
th
It would be nice if they had the rules maybe somewhere to the side where we could reference them. Do you have it, Brian?
so I memorized the rules for this one. So the third rule is it just has to equal to one.
Yep.
And then the first rule is it can't be negative. And the
Okay.
second rule, it says just the big X equals X. So I noticed anytime there's the negative, it violates rule 1 and 2. And then the
Yeah.
probabilities still add up to 1, so it does not violate rule 3. So that was my question, as I didn't understand the second rule and what makes it, click.
I'll tell you what, I'm gonna let me back out of this and I can give you guys like a quick 2 minute discussion of what a probability mass function does, if you don't mind. I can do that on my overhead. So a probability mass function is basically if you've got a scenario where, like you're flipping coins or rolling dice or something that can be described randomly but using probabilities, we create a function. So for example, if I flip 2 coins, I can get tails, 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 heads, heads, tails, or heads, heads, right? Those are my outcomes. Would you all agree with that? So that's basically the possible ways that 2 coins can land. What happens next is we have to define an outcome. So we have to look for we're looking for something that we're interested in. So for example, I might say let big X equal the number of heads. Okay, so big X can be 0, 1, or 2. Now these values here become your little x values. It gets a little confusing, but it's just that this is basically the translation from a real world situation to an arithmetical one, to where we're creating uh, numerical equivalents to an outcome. Because right here, if I'm flipping 2 coins, I'm getting tails and heads. I'm not getting numbers. So I have to make a translation over here saying, well, I'm going to let big X be the number of heads that shows up. Well, I can either have 0, 1, or 2 heads. And then I go through each probability. So the function will be written like this. It looks a little weird. Hang with me here. Okay. It's basically the probability mass function for a particular outcome is equal to the probability of that outcome. So for example, the probability mass function for the outcome of 0 is equal to the probability of 0 heads. Well, that would be the tail-tail outcome, so 1 and 4. The probability of big X equaling 1 is or I should say the probability mass function is the probability at 1. Actually, I might have this backwards, it doesn't matter. So how many ways can one head appear? 2, so 2 out of 4. Actually, not, you know what? That's whatever, I'm just gonna go with it. And then I could have 2, and I can see right here, there's only one outcome that does that. And I've got my probability mass function. Basically, I have 3 points. I have 0, 1, and 4, 1 over 4, 1 and 1/2, and then 2 and 1/4. And these 3 points are a probability mass function. And that's really all there is to it. You can't have negative probabilities, they just don't make sense. And they have to add up to 1, which they do. And then really the middle rule, I guess, is just kind of the translation between the experiment and then the outcomes that come from that experiment. Okay. And that's pretty much it. That's all there is to it. Does that help or hinder?
Yes. Yeah.
Yeah,
Okay.
yeah. I think the only thing I just need clarification on is just like the second rule, but because
You see?
I get like yeah that non like no negatives add to one I think are like fairly simple to remember, but that second rule I don't really know when it's like supposed to be implemented, and then like when there is negative numbers, sometimes it says like yeah it violates the second rule, but other times it's a negative number, it doesn't violate the second rule. So
The
I'm just
first
kind of like
the first number can be negative. So when you have a set of points, it's okay to have the first number negative.
right, yeah, yeah, yeah. But it sometimes it's saying like this when the second number is negative, like it violates the rule because it's a negative number. But then other times it like it doesn't violate the second rule, which is like a little weird. I don't really have like a set example ready, but I think it's just like when I've been doing some of the practice or like going through some of it, I've kind of just like messed up a little bit. I just,
Okay.
I think
Um, yeah, really, it's really just those two rules. You just can't have negatives and they have to add up to one. That's pretty much it. Um, the rest of it is just simply the translation between going from like something that's inherently non-numerical to something numerical.
of course, okay.
That's really all I guess that's what the second rule is saying. It's just saying that the probability mass function at that x value is the probability of that outcome occurring. Now, I suppose you could just simply create a sentence that just simply outright denies that, and then rule two is broken. But if you just have a set of points, it's either going to be rule one or rule three, apparently, by the way they're numbered. All right. Well, are there any last questions?